Okay, so here's 9.5, and you can see that I have drawn a straight line, a tangent at 300, because they have mentioned that you have to find out the activity of this radioactive source at 3 after time, or at 300 seconds. So for that, I have drawn a tangent. Why? Because I have to find out the gradient of the graph at this point. And you should be very much careful that the tangent is a line which always touches the graph at one point. So your graph should not be touching the graph at any other point. If your tangent is touching the graph to at some other points other than this 300, you will get 0 mark. Be careful with that. Okay, so I have taken one point which is A and the other point which is B, and I have measured the readings at these points according to my own drawn tangent. Okay, so here the reading is 4.85 and here the reading is 1, and now I am calculating the gradient, which is rise over run. And rise means final minus initials. This is my final value and that is my initial value. Okay, that is my initial value. And final minus initial is actually the one will give which will give me the total rise, and the total run is final minus initial. So the final one is 550, which is here, and the initial one is 0. So when I do that, I am going to get 7 into 10 raised to the power 20 per second. That is actually my activity. So that is question number 9.5. Okay, now let's get back to the question paper. And here the activity is simply 7 into 10 raised to the power 20 per second, or you can say back row, BQ, because back row is actually the unit for the radiation, the SI unit for the radiation. Okay, so question number 10. The live wire in a 3-core cable is connected to a fuse inside a plug. A fuse contains a wire that is designed to melt when the current gets too great. Figure 17 shows a fuse. What color is the insulation covering the live wire in a 3-core cable? So we know that the brown color, we have three colors actually: brown color, blue color, and the yellow. Okay, so brown, blue, and yellow. So the brown always shows you the live wire which carries the current. The blue wire always shows you the earth wire. It's just for your information. And the yellow wire, which is actually having like green and yellow strips together. Okay, yellow plus green strips, it actually shows the ground wire. Draw the circuit symbol for a fuse in the box. So here's the box and here is your fuse. The line strikes through the box. The fuse wire melts when there is a charge flow of 2 coulombs for 400 milliseconds. Calculate the current in the fuse of the wire. So again, if we go to the physics equation sheet, we know that the current is equals to charge over time. Charge is Q, which is coulomb, and this is your time, and it is millisecond. So it should be 10 raised to the power minus 3. And we need to find out the current. So current is 2 coulombs divided by time, which is 400 into 10 raised to the power minus 3, because you have to use the SI units, and the SI unit for time is not millisecond, it is seconds. So when we get the answer for that, it's 5 coulombs per second, and the coulombs per second is actually amperes. Okay, and in short we write that as A. So therefore 5A is the answer. 1.4. When the fuse wire is at its melting point, the additional energy needed to melt the wire is 1.02 joules. Specific heat of fuse of the wire is 60 kilojoules per kg. Calculate the mass of the fuse wire. Okay, this is an important question. Now, when the wire is melting, it is actually changing its status or its state, because previously when the wire was not melted, it was solid, and now it is melting, so it means it is becoming liquid. And the amount of energy that is required to change the state of the object, for example, the amount of energy which is converting the solid wire into liquid wire, is always called latent heat. Okay, so latent heat is the amount of energy to change the state. Energy needed to change solid wire into liquid wire because it is melting. Okay, and for that the formula in the physics equation sheet is Q equals ml. So that is actually your L, which is latent heat, and that is Q, which is energy. Now this energy is in kilojoules, so again you have to write that 60 into 10 raised to the power 3 joules per kg. So you need to find out the mass. So just put in the values. 1.02 equals m into 60 into 10 raised to the power 3, right? And from here you are going to get this, and therefore the answer is going to be 1.7 into 10 raised to the power minus 5 kg. Last question for this paper. The calculation in question 10.4 assumes there is no energy transfer to the surroundings. How would the time taken for the wire to melt be affected if some energy was transferred to the surroundings? That is simply means that some energy is lost. So if some energy is lost to the surroundings, of course the wire will take more time to melt, because more energy will be lost to the environment. So it means that you need extra energy to melt the wire. So here is the end of the OCR 8463 higher type paper 1 for 2024 May. And thank you very much for being with me throughout this video, and if you liked it, please like and subscribe my channel and share with your friends and family members. And if you need any help in physics, or if you need any tutor in physics, please reach me out on the given details on the top of this video and also in the description of the video. Up till next video, it's goodbye, and thank you very much for being with me. God bless you and take care.